In this video, we're going to show that the Vander Waals equation of state can also be written as a polynomial of the form V cube molar volume cube minus B, which B represent the strength of repulsive attraction between molecules plus RT over P, close the bracket, molar volume squared plus A, which A represents the strength of attractive interaction, close the bracket, molar volume minus A B over pressure is equals to 0. Now, we are going to start by writing the original Vander Waals equation of state, which is P is equals to nRT all over V minus NB minus N minus A N squared over V squared. This one is the original Vander Waals equation of state. And we realize that we can also write the equation in terms of molar volume, which is now equation in terms of molar volume. In terms of molar volume, which molar volume can also, we can say that molar volume is equals to volume over N, which N is the number of moles. Which N is the number of moles. But Vm is equals to N over N can also be written as V is equals to N Vm. Right? Hope you are following. I'm saying that equation in terms of molar volume can also be written as V over N, but molar volume is equals to V over N, which V can also be written as N Vm, number of moles multiplied by molar volume. Then we write then we replace this one in this, we replace where we have V in this equation, we replace it by moles, number of moles times molar volume. Now, P pressure is equals to nRT over where there is V, we replace it with this one. Now, NVM minus NB minus AN squared all over NVM. This one now also squared, right? But you can see that this one and this one, they are the same. Now this one will cancel. This one will go with this one. And also you see that this one also, this one, they are the same. Now if you cancel 1 year, also you cancel 1 year. You cancel this one also. You cancel this one and you cancel this one. So we remain with P is equals to RT all over Vm minus B minus A over Vm squared Now we will write that this one is equation 1 and this one is now our equation 2. Now that one is our equation 2. Now from this equation, let's multiply both sides by the LCM. Let's multiply both sides by the LCM. Now you multiply both sides by the LCM, LCM, which LCM in this case, LCM is VM minus B, close the bracket, into M squared. Now that is the LCM. Just multiplying this one with this one, then we get the LCM. After that, hope you are following. After that, we multiply both sides by the LCM. Now, if you multiply this side by the LCM, now we are getting P VM cubed minus PB V squared M is equals to RT V squared M minus AVM plus AB. This one is what we are getting after finding the LCM. After finding the LCM, if you multiply both sides, we are going to get this kind of equation. This kind of equation. Now PV cubed M minus PB V squared M minus this one going this side minus RT V squared M, now plus AVM minus AB. This one will give us 0. That one will give us 0. Then the next thing, we divide by P. Divide by P both sides. If we divide by P both sides, we are going to get this. This kind of equation. If you divide both sides by P, we are going to get this kind of equation. Now V cubed VM cubed minus BV squared M minus RT V squared M over P plus AVM over P minus AB over P, which is equals to 0. And that is what we are getting. Then we recollect each terms, because here you see that we have here we have a molar volume squared, and here we have also molar volume squared. Then why can't we correct it so that we only be with a molar volume squared, one molar volume squared, which we will have V cubed M minus bracket B plus RT over P into V squared M plus AVM over over P, right, minus AB over P, which is equals to 0. Now that one is our final equation 3. Now we see that from what we are told, we have already rewrite the normal van der Waals equation of state into the other form, which is this one. Now, thank you very much for watching this video. Kindly subscribe to get more videos which I will be posting soon.